Good morning, everybody. We don't have a lot of people in the class, but they're slowly trickling in. Welcome to this Wednesday, where we are starting a new chapter, our chapter on Babylonian numbers. Very exciting. All right. While we're waiting, can I get confirmation that everyone can see and hear me while we're waiting for people to come in? All right, so what we have done so far is look at a different number system from history, the Roman number system, in a way that helps us with our goal. And our goal is to not fundamentally change what we're used to doing in arithmetic, but change things in appearance, change things just a little bit so that we are forcing ourselves to be aware of how our number system works, how our methods of arithmetic work, and just be very critical and really carefully think about it. Because if we do those things in our decimal number system, those things are so familiar, I immediately shut down my thinking and just go through the motions without realizing what I'm doing anymore because of the repetition I've been through my whole life. But as a teacher, potentially, I really need to be aware of every little thing so I can adapt my explanation, I can focus and elaborate on one step, I can guide the student more effectively. And that requires that I really understand what I'm doing first. So to help us, we have a couple of number systems that are very different, but both help us in that goal. We finished the Roman number system, and we are moving on to the Babylonian number system. Now our goals will be the same. We are just looking at another number system, and we're looking at number systems that have a connection to our modern world today still. So we're not going to look at very strange number systems that have completely died out in terms of what we see today. We still have a connection to these. We saw with the Roman number system, it's fundamentally decimal. And we still have a connection to that, of course, because we count in tens as well. The Babylonian number system is going to look, I think, much different, but we still are connected to it. And I challenge you to think how as we continue. Now, to highlight the Babylonian number system, we have a little video. But before we start the little video, just explaining and sort of demonstrating, because I'm not in class to physically show you. The Romans had connections with Egypt, and therefore they had a sort of a paper resource that they could write on. Great. So their number system reflected the writing options that they had. The Babylonians, however, did not have access to paper. So they couldn't write things down in ink in the same way. So they had to be a little bit more creative. How do they keep a record of quantities, of things, as they're trading, as they're assigning land, as people need to pay taxes, all these important things? What they did have a lot of access to is clay. So they decided to use this clay medium to represent their numbers. But of course, you can't write on clay as you could with ink and paper. So how do we represent numbers then? So I am going to play a little video. I just need to change my screen sharing option so that you can hear the video in Discord. Give me 1 second here. Why am I not seeing it? Let me open it. Where are you? Okay, here it is. Okay. So let's see if that works. And if not, you can always watch the YouTube video after the fact if you maybe can't hear audio, but it should work. Okay, let's go.
Now all you need is a small piece of clay about the size of a golf ball or a table tennis ball, and to squash it out into a small disc. Here's our clay tablet ready to use. A small stylus. I've just cut mine from a piece of dowel, but in the old days I believe they used to use reeds, and then they used to cut timber much this shape. They used to draw lines, so I'll just draw some lines here quite a distance apart. They used to be a lot smaller, of course. And believe it or not, for all the sophistication of their number system, they used just two symbols. One of them was this one. Just poke a small mark into the clay. That would be the number 3, and they kept going. 4, 5, 6, 7, 8, 9. Easy. The next symbol they used was one like this, which represented 10, and they could make 30, 40, 50. The number I have represented there is in fact 59. If they wanted to represent the number 23, they do 1, 2, and 1, 2, 3.
Okay, 1 second while I switch the screen back here. Okay, now we're back. Okay, so move my microphone here. Okay, so now, of course, as much fun as it would be to play with clay and make these markings, we have to compromise and make these symbols that they would make in the clay by just drawing them on paper or the screen. So because of that, it'll seem a little clunky and inefficient perhaps, but remember, we're just representing the symbols. We're not doing it exactly the same way they would have done it. Babylonian number system. Okay, I'm just checking my mic is working. I think everything's good. Okay, so because of their clay limitation, and they didn't want to swap out their dowel, their instrument, their stylus, that's a better word, they only had the option really to angle it in a couple of different ways. So to represent 1, they made a little indentation. There's a little flag-like symbol, right? You can try and copy the font I have here. Zoom in, zoom in, zoom in. This is the font that you'll see in the book, the only one I could find. Sort of trying to represent that indentation that you could get in the clay, just a little vertical line. Now I like to have my own style, but after a while it might look a little different. I recommend you try and make the symbol as you want, but don't just write a line like that, right? Be a little bit more creative so that we can see it's not the decimal digit 1. And then for 10, they would angle it sideways to make this little less than sign, like, or a little eye, sort of, whatever you might see, or a little mouth, or whatever you can visualize that to be. They had to angle it in such a way that it's visibly a different uh, symbol that they're making, right? But if you have too many, then it's going to be hard to really make them obviously different, as people will have their own style as well, slightly different angles that people might have. You are kind of stuck in the sense that you can't allow many symbols because you need to make sure that regardless of who's making these indentations, if they know how to write, it'll still be recognizable. Just like handwriting. You still need to recognize the letters that the person writes, even though it might be a little different. So they decided, okay, we can get away with 2 symbols. And that's unfortunately it. Now we have to build a whole number system with 2 symbols so that our civilization can grow and develop and not die out. That is not a simple feat at all. What did they do? Well, for reasons that aren't completely known, they're only theories, they decided to just start listing these numbers, just start stacking these symbols together. So let's write the first few. Oh, stupid line. So let's write the first few. And then as we do that, we can practice how we want to make these as well. So 1, 2, 3, 4, 5, 6, 7, 8. Of course, our first task is to convert, right? So let's say from decimal. So there I'll have my, how do I write my little flaggy? How do I do it usually? My little flaggy guy. And then I could maybe write 2 of them. Sorry, a little longer perhaps. Just stack them. And then stack 3 of them. So as you practice these symbols, you'll find a compromise between it being recognizable and it being fairly fast to write. 4, I'm going to, let me just zoom in a little bit. I don't know why I put them so close together. They decided, well, it's going to be recognizable. I'm going to leave myself some space here. It's going to be more recognizable if I just put 3 in a horizontal row. And then I'm going to start stacking them underneath each other. And I'll put the 4th one, make it a little bigger so they seem connected. 5 would then be a row of 3 and then 2 underneath. 6, I didn't give myself enough space, so I'm staggering them. 6 would be a little smaller, but 2 rows of 3. And then I just keep going like that. But I'll have to have another row of 3 for 7. And for 8, see, mine look like little peas or little flaggies, and that's okay. For 8, I'll just start stacking them 3, 3, and 2. And 9, of course, will have 3 rows of 3. And the more rows I have, the smaller I'll make them. And then 10, whew, finally, I have a new symbol. Okay, whew, that's a relief. All right. So by doing this, we're practicing how do we want to make these little flaggies. Mine end up looking like little flags or little peas, sort of pointy peas. As long as they are visibly different, these 2 symbols. And you only have 2 symbols to memorize. It can't be easier. 2 symbols? Who can't remember 2 things? So then 11 would simply be a 10 symbol and a 1. nice and close together because they are one connected representation, one quantity. 12 would be a 10 symbol and 2 ones, and so on. Nice and connected, like so. My flaggies get a little wobbly after a while. So let's skip forward and say, okay, what about 23? Then I would simply have 2 10s, and I'm stacking them sort of diagonally, and 3 1s. Nice and tight, because it's one quantity. Let's skip forward, and let's say we have 40, let's go 7. So now I'm going to stack the 10s. I just want to be as authentic as possible, right? I'm going to stack my 10s diagonally until I get 3, and then, ooh, that was a curly one. Wow, look at that. It's nice. I like that, actually. I can do better than that. Let's be a little more clear here. My 10 symbols get a little curvy when it should be nice and sharp. Right, nice and sharp. Sharp. There we go. That's better. And then 7 will be a row of 3, another row of 3. See, I make them smaller so that the height is roughly the same. So it's now nice, one connected thing. One quantity. But using repetitions of those 2 symbols. Okay. So I got a little excited, but we do actually have problems. Not problems. Why do I keep saying problems? We have no problems. This is fun. There's no problems here. We have exercises. Yeah. Let's look at an exercise. First kind of conversion in exercise 6.1 is, of course, given a Babylonian number, what is the corresponding decimal number? So let me just number this. Exercise 6.1, number 1A. I'm not going to copy it. We can just look at it. That is 2 10s, so 23. 23. Nothing more to do. You just have to understand how the system works. And in the first step towards understanding, it's as simple as just adding up all these pieces. They're just repeated to form the quantity. What is the second quantity? Well, now I have 4 10s, so 40. Oh, it's 47. That's exactly the one I chose. Wow. That's not very original. I'm sorry. Who made these examples? Silly. Now, this is the font that the book is going to use. So they stack them like this. It's the only font I could find. Lay them out however you want, as long as they are nice and tight together when it's one quantity. So here I have 39. 39. So they decided that, look, if I have too many of these one symbols together, it's going to start blurring together, and I can't quite tell them apart to see how many there are just by looking at it quickly. 9, if I stack them 3 by 3, okay, I think I can handle 9. But any more, so let's get a new symbol for 10 and then use that so that we don't repeat the same symbol too many times. Okay. So they said, okay, 9 of these little ones and we're going to be okay. And the 10s are a different symbol, so we don't have an issue right now. All right. Then, of course, we want to convert the other direction. And here in the example, we have 22 to convert. Well, that would be 2. Oh, my 10s really are not good today. Let's make them nice and angled. Angled. If I want to write them, I can write them in a row. What was the other one? 22? Yeah. And then nice and tight, 2 1s. It doesn't have to be perfect. I, of course, made this look sloppy on purpose. Usually my writing is perfect. Just to show you that it doesn't have to be perfect. You just have to keep them tight and make the 2 symbols recognizable. That is my requirement. We don't have actual clay. If you had clay, it's actually very easy to do. It doesn't feel easy, perhaps, when you write it. It feels clumsy and you have to draw pictures and it doesn't work. You have to figure out how to draw this. But in clay, it's very efficient. You make indentations and you just go like the video showed. But sadly, one downside of having a virtual classroom, it's not as efficient to work with clay. But we do the best we can. To try and imagine that it was, in fact, very efficient. There's a picture there. The guy just, from the video, actually. I stole it. Let me zoom out. Where's my exercise continued? Oh, over here. So before we get to the rest of the exercise questions, you see here they listed some representations of the first 20 and just sort of a cluster of these symbols repeated. So 30 will just be 3 10s. They're nice and tight together. So there's no question that this should go together. Whether you want to stack them like that or you want to stack them like that, doesn't matter to me. I think historically speaking, the second one is more correct or more authentic, rather. They're both correct, but it's totally up to you as long as they are clearly together. And lastly, we have 48. So we want to have, oopsie, I don't want mine to look too much like a 4 sometimes. 48. So I have a row of 3, another row of 3 will be 6, and then 2 more. Nice and connected. See? Cluster of one quantity. Okay. How do we feel about that so far? Try and keep in mind that if they had the option of drawing on paper, they wouldn't have done this. Of course not. But given their situation, they decided to rise above it, figure out what would still be efficient, and they went with it. And they were very successful. Very, very successful in this number system. And a key to a growing civilization, especially at that point, and really in general, is effective communication, whether it is language, whether it's numbers. It has to be effective in use and maybe in writing so that you can grow and share knowledge and convey information effectively. And that is exactly what they did. Any thoughts at this stage?
It sounds pretty cool. Does it go into like the hundreds and different
Yeah,
symbols
see,
like
so
that?
now our issue is, okay, so if you notice, our numbers have been fairly small, and for good reason. I just want to get into how this works. But they had to make a decision. Obviously, I can't stack too many of these. I limited myself to only 9 of these ones symbols. Okay, so let's say here, limit ourselves. They decided, look, if I have too many of these symbols in a cluster, I'm going to start losing my efficiency. I'm going to start having to look really carefully at how many of these one symbols there are, and it's going to slow me down, and I can't read what I need to read, and it's a whole bunch of problems. So they decided, okay, we're just going to have up to 9 of the one symbol. Too many, and it's going to break down. So let's draw 9 of them. to help us, sure, we stack them like this. It helps. But anymore, and even the stacking is not going to help me anymore. Okay. Nice and close together. Fair enough. Anymore, they thought, it's going to be too bad. Okay. So we stop at 9. Okay. But we can have some 10s to make the quantity bigger. But they decided, well, based on the symbol, we don't want this cluster, this representation to be too big in either direction. So really, when we make a cluster of 10s, we can stack them. That's pretty much as far as I want to go. So they decided, I didn't decide it, they decided up to 5 of these 10s symbols. Maybe trial and error, slowly over time, they realized that, okay, this is as far as we're going to go so that we can still see very quickly the quantity and read it and move on with our lives. Anything more, and it slows us down and we really have to stop and count, and that's not how you want to look at a number and know what it is and move on. So that's as far as we are going to go. So this is equivalent to 59, right? But of course, I could be a farmer and have more than 59 chickens, and I need to pay taxes and keep record of my chickens and whatever else I need to do. So obviously I need to be able to represent larger quantities. What they decided is we are going to count in groups of 60. So now if I add one more here, if I have one more, now I have 60. How do I represent that? Well, if I have a larger quantity, like, for example, let's say I have 64. The actual 60, we're going to have to wait on that a little bit. I'm going to just write it in my language first. I'm going to say that is one group of 60 and another 4 left over. So now I'm going to have 2 places in my number system separated with a clear space. I'm going to have one group of 60 space and then 4 ones. A clear space will indicate that this is a 2-place number. It has 2 places. The left place, the first, if you read left to right, is going to indicate how many groups of 60. Groups of 60. And the second place, the next place down the line, is going to represent how many leftovers. Oops. Or ones, or whatever you want to call it. How many is left over? So one group of 60 and 4 more in addition to that gives me 64. So in that way, by having multiple places, I can recycle existing symbols. Now, I mean, this isn't that foreign, really, when you think about it. That's exactly what we're doing in our decimal system. Except we say, let's say 24, and I'm going to write it in words so it looks a little strange. 24 is 2 groups of 10 plus another 4. It doesn't matter how I have represented it here. I could represent it in words. I could have symbols. I could make my own symbols and say, this is how I'm counting. Our decimal system is going to make groups of 10. They decided, we like 60. Why exactly? No one really knows. There are some theories that in terms of surrounding numbers, 60 has the most ways of breaking it up into smaller factors. The other numbers around it of that size doesn't work as nicely as 60 does. but still, we don't really know. And it's interesting. I think it speaks to the culture, the way of thinking at that time. Uh, a lot of it can be sort of concluded or gained from looking at how did they do things? What did they feel is a natural way to move forward, like with numbers? 60. What does that say about the culture of that time? I don't really know, but it's interesting. Regardless of the reasoning, they said, we are going to go with 60s because we're happy with representing quantities up to 60, up to not including 60. Below 60, we're happy with making clusters really one place. This is one place, a one place number. We're happy with making little clusters like that. With our clay, super efficient. We have no problem. So they didn't have the need, like we perhaps did, to stop at 10 and make more places. Let's see now, there's a place for the number of tens, 2. There's a place for the number of ones, if you will, units, leftovers, whatever. And we write this in 2 places because we are basing it on 10. They were fine going bigger because their symbols allowed that and still had that readability to it. But too much, we're running into trouble. Let's cap it at 60. Okay. But in terms of a place value system, it's really not that foreign once you think about it. Place value system. So let's look at some exercises. And the next one is exercise 6.2. Let me zoom in. Now, I don't want to go too fast here. We've got lots of time. We have tomorrow as well. So we definitely have the time to just ease into it. Ease into it. But the place value concept is a key concept of this number system. So we have, of course, the task of how am I going to draw the symbols? Get used to that, making your little clusters. Do that first. Then worry about, okay, well, now I have to think of multiple places of clusters as well. But one thing at a time. Number one. Number one, A. So now I see I have 2 places. The space should be super clear. There is, of course, maybe a little gap there in my font, but obviously, it should be obvious that the 3 tens and the 5 ones make one place, one cluster. And there's a clear space, and then this 1 is a new place. I have 2 places. That means from left to right. I'm counting. Let me write this out. I have time. Why not? I'm going to write, let's do it like this. Number of 60s. And then number of ones. Let's say it like that. Okay. So in the 60s place, I got 1. Let me maybe write it like this. I'm going to put it in brackets because I'm not done. I'm just trying to figure out crossing over to my complete conversion. So make the brackets remind me, I'm not done. I'm just seeing what there is in that place. Okay. Then in my next place, the ones place, I have 35. 35. So that then means I have one group of 60 plus 35 left over. So therefore I have 95. So this 1A Babylonian representation is the representation for 95. So maybe something like this with lines reminding me what the places are doing with numbers in brackets because I'm not quite done. Maybe that helps me. Use it. Help yourself. Especially if you happen to make a mistake. Like in the heat of the moment, I'm rushing because it's a test or whatever reason, I'm not paying attention, and I accidentally write 94. Having something else there to show that I do understand how to do this. I showed my work. I show understanding. I just happened to make a little mistake. That's always a good idea to have that backup, to get part marks if that is available. If you just write 94 with nothing else, then it's a 0 because I don't know if it was a silly mistake or you actually didn't have any idea how to do this. So showing some work is nice. But of course, you can figure out exactly what you want to show and how you want to show it. This is an option. Okay. Next up in B, again, 2 places. I'm going to set this up. And hopefully in the first quiz, you saw that there was more than enough time, I think. If I'm well prepared, the time should not be an issue. So I set it up. 2 places, so I'm counting 60s and then 1s from left to right. Let's see how many groups of 60 there are. There are 3. And then for the 1s position, the 1s place, there are 41. 41. And of course, you have to get to a point where you can very quickly recognize there are only 2 symbols. This is really not that difficult. So I'm setting myself up, and now I'm ready to say, okay, it's 3 groups of 60 plus another 41. So that would be what? 180 plus 41, 221. So this Babylonian number corresponds to what we would call 221, 221. And again, find a way that helps you get to that answer with confidence and show some work in the process. It's win-win. It helps you, it helps me, it helps everybody. But of course, it's day 1 in Babylonian times, so it might take a while. I'm only going to do this exercise, and it might be a good place to stop. We're not in a hurry at all. We have tomorrow as well. And then we'll start arithmetic. One thing at a time. Let's build up slowly and correctly. Okay, so we have a 2-place number. All right, so I'm going to help myself. I'm going to set it up. If you think that is silly, that is totally fine. And if you have the number correct, it'll show. Oh, sorry, I'm multitasking here. Multitasking is not my strength. Let me just finish what I was trying to write here. You can't anyway write just 221. At the front in the instructions of the test, it says show sufficient work to justify your answer. So if you want all the marks, you're going to have to show something. But exactly what that is, it's up to you. Okay, so we have 10 in the first place. So 10. Then we have 50. So 50. Of course, I'm not done. I've just sort of translated each individual place. I have to put it together in that system for how it works. So I have 10 groups of 60 plus 50 left over. That's, of course, 650. Okay. How do we feel about this direction for the conversion? Of course, it takes time. You may need time to review. Just slow down and think about it, and that's where the videos are very useful, or do whatever you need to do. Okay? It takes time. Don't be worried about time. We have the time. It's okay. No, I don't think I have enough space there. Let us see the other direction for the conversion. All right, so now we're doing number 2. First one, I'll write it down. 100. 100. Okay. Now I know how the Babylonian system works. It's counting in groups of 60. And I have a number that is bigger than 60. That means I need to split it up. And in this case, I have one group of 60 plus 40. So I need to do this breaking up of the number according to groups of 60. That will then mean I'm going to have a 2-place Babylonian number. The left place is going to count the number of 60s. That was supposed to be an S. 60s. The next place is going to count the number of 1s. I have one group of 60, 40 ones. Maybe I want to help myself like this. Sort of that transition to Babylonian places, but I'm not going to worry about the symbols just yet. Now I'll do the symbols. A 1, nice space, and then 40 stacked however you want to stack it. I'll stack it like that. Just get some curviness into that line there. Not my best 10 symbol, I know. Nice clear space in between. All right. So this direction has maybe a little more to it, that I have to take that decimal quantity, 324, and I have to break it up and say, well, how many 60s can go in here? Into 324, I can fit 5 groups of 60 in. That uses 300. And I don't have enough for another one, right? I have 24 left over. But I need to do this breakdown correctly, of course. Then I can go and say, okay, I have 2 places for the Babylonian system. First one is the number of 60s, and then the number of 1s or leftovers or whatever you want to call it. I think people call it units, but that never sounded right to me. So I'll have 5 groups of 60, and I'll have 24 left over. That means I need 2 places. I need to represent 5 stacked however I stack it. I like this stacking. Nice space. 24. Oops. Technically, if it's not 3 in a row, it's a little bigger. But whatever. You see the clusters. You see the space between them. Exaggerate that. Nice and tight. Nice and tight. Space. Space. Okay.
I just have a quick question.
Yes. Hold on. Let me turn your volume up.
Oh, okay.
There we go. Okay.
Okay. So if it's only 160, then we just do that first symbol, like the flag?
It's however, whatever this number is, I convert that to Babylonian.
Oh, I see.
In that case, it's a 1, so I write the 1 symbol.
Okay. And
Oh,
then
sorry.
on the next one, though, it's
Sorry, I am way
5.
off. I am just smoking something. I don't know what I'm smoking, which is ironic because I don't smoke. I wanted it to be more than it is. It's not. I'm sorry. This is just a 5. So that would be 5 ones.
Flags. Okay.
Yes.
Okay, that's good.
Of course, I mean,
Thank you.
of course, I did this on purpose. Just to
Yeah,
see
just to make sure we're paying
who's
attention.
paying attention. And you passed. You paid attention. See? You passed the
Okay,
test.
that makes sense. Thank you.
Yeah, I don't know what I was thinking there. Let's go with I did it on purpose. So, and in fact, I mean, I'd say this middle step helps me look back and say, okay, did I do this right? Okay, this was supposed to be whatever this in this place. I just convert to 5. Oh, did I do that right? No, I didn't. Okay, let's go fix it. But I have this helping step that might help me catch a mistake, like I have demonstrated here. But you, of course, don't have to write a middle step. Just show the breakdown in terms of 60s and then go to Babylonian, or however many in-between steps you need to help you get there with confidence and have a little safety built in like we spotted it. By having that extra step, I spotted, with some help, the fact that, oh, I didn't represent 5, I represented 50. And that helped me realize that before it was too late. Now, of course, if the number is a little bigger, then figuring out how many 60s can go in there can be a little tricky. You can totally do it in your head, trial and error, do whatever you want to do. But we can also just do a division, because how many times 60 can fit into a number, that is exactly the intuitive understanding of division. So let's see what MathBot says if we do 1337 divided by 60. 7 divided by 60. Hopefully MathBot is awake. MathBot says it is 22 and a little bit more, but not enough for another whole group of 60. So 22 groups of 60 will fit into 1337. Then I might want to know, okay, well, how much of that number have I used when I look at the 60s? So 22 times 60, and I see that I've used 1320. So obviously then there are 17 left. Now, maybe I'm not 100% confident here. I can then go and triple check and say, okay, let's see what this calculation is, and is it 1337? So 22, oops, I need 2 equal signs. 22 times 60 plus 17. Did I do that right? Yes, I do get my original number. Okay, now I'm doubly sure. But definitely this direction for the conversion is more difficult, in that I have to figure out this breakdown of the number by way of 60. Once I have that, regardless of how, you can go and say, okay, I like the safety step. It helped me catch my previous mistake, so I'm going to keep doing that. It's not as if it takes very long. I am going to have 22 groups of 60 and 17 left. Now I just have to convert 22. That'll be 2 10s and 2 1s, nice and tight. Big space. Well, not too big, but big enough to be recognizable. And then 17. 17 has a couple of rows of 1s here, like so. I don't love this line here. It's a little straight. Make it nice and curvy. Something like that. Clear space, clear clusters. I double check. 22, yes. 17, yes. I'm good to go. Okay. So write enough, especially in the beginning. Show enough to yourself. Don't think just about the test. Help yourself. And what helps me is to see my thinking, so that if I get distracted by a bird outside, oh, okay, I'm back. Oh, right, this is what I was doing, because I see it on the page. People think they want to write as little as possible because it impresses, I don't know who, someone. I can't think of who. Help yourself. Write more. When in doubt, write more, so that you can see, and everyone can see, what your thinking is. It's just better for everyone. Okay, so this is a good place to stop. More than enough things to practice. Of course, the story isn't finished, but we have tomorrow in the schedule, so why not use it? Plus, we're out of time anyway. Any last thoughts before we pause it here and pick it up tomorrow again? I know, there's stunned silence. That's okay. Until tomorrow.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.